Let's take a look at this problem from section 4.4 in your lab assignment. It says to find the limit, use L'Hopital's rule if appropriate. If there is a more elementary method, consider using it. So we're looking at the limit as x approaches infinity of ln of 5x divided by the square root of 5x. So as x goes off to infinity, ln of 5x is going to go to infinity because the ln function is an increasing function, and similarly the square root of 5x is going to go to infinity. So that is an indeterminate form, infinity over infinity, so we get to use L'Hopital's rule. So this is an infinity over infinity. We use L'Hopital's rule by taking the derivative of ln of 5x. So the derivative of ln of 5x is, I'll write it down here in steps. It's 1 over 5x times the derivative of the inside of the function is 5. So you can write it like this, and I'm sure this will take it properly, but you know, this is something that's easy enough to cancel, the 5 in the numerator and 5 in the denominator, so it's really just 1 over x. The derivative of this thing, if we write the square root of 5x as this 5x raised to the 1/2 power, the derivative of that is going to be 1/2 times the inside, and then we're going to raise this to the negative 1/2 power. It's subtracting 1 from 1/2. So this, I don't know if we can simplify this very much, but we'll just go ahead and submit it. Oh, we forgot something. It looks like we forgot to take the derivative of the inside. So there's going to be an extra 5 that should pop out of this. So let's put times 5 here, and let's move that. So we see that the derivative of the inside here is 5, and we have to multiply by 5. Okay. There we go. So now we have the derivatives. We'll put these derivatives up in the numerator. So the derivative of ln x, or ln 5x, is 1 over x. The derivative of the denominator, written in some other way, is 5 divided by 2 times the square root of 5x. And so using some rules, we can just multiply by the reciprocal, and then we're going to get 2 times square root of 5x divided by 5x. So if we have the square root of 5x divided by 5x, that's like 5x to the 1/2. Maybe we should write that down here. That's 5x raised to the 1/2 power divided by just 5x raised to the first power. And so if we follow the rules, we are essentially subtracting the powers. So this is equal to 5x raised to the, well, it's going to be 1/2 minus 1 power, and that's going to be a negative 1/2 again. So the negative 1/2 can be shown as a square root in the denominator, so this is just a regular plain old 5x. Okay, well, let's make sure that this is clear. This whole thing is equal to this thing raised to the negative 1/2 power. So let me just do some fixing up. Negative 1/2 power, and that in turn can be rewritten. Oops. That in turn can be rewritten as a fraction, where you just have 1, and then this thing is actually the square root of 5x in the denominator. Okay, so that's our denominator, square root of 5x, and then we'll go ahead and check that. So now that we've simplified it, we're going to take the limit as x approaches infinity, and you have a constant 2 on top, and the denominator gets larger and larger, so this thing goes to 0. And since now we have a definite number, or if it's undefined, but we have a definite number here, then the original problem must also go to 0. Okay, so that's one use of L'Hopital's rule.